So hello everyone, let us solve today's GFG problem of the day, and the problem name is XOR Linked List. Now this is a very big problem statement and little bit difficult to understand if you don't know what is a XOR Linked List. So I'll first explain what is XOR Linked List, and then I'll make you understand what the question is asking us to find out. So let us see with the help of one example how we can solve this question. So first I'll explain you what is XOR linked list, and then we will find some solution for this problem. So let us understand now. First of all, we need to understand what is a XOR linked list. So before understanding XOR linked list, we also know what is a doubly linked list, because these both are related to each other. So doubly linked list you might know. So it is a kind of linked list. Let me just draw it out for you. So in doubly linked list we all know that there are two pointers. One is next pointer, one is previous pointer, and here also one is previous pointer, one is next pointer. Similarly here. So this next pointer would be pointing to this node, this next pointer pointing to this node. This previous pointer would be pointing to its previous node, this previous pointer would be pointing to its previous node. Similarly, this previous would be pointing to null, and this next would be pointing to null as well. So yeah, we can write here null also. So this is what doubly linked list is. So what doubly linked list do is, doubly linked list maintains two pointers for going ahead in the linked list and going backward in the linked list. But making two pointers would take a little bit of extra memory. So that's why XOR linked list was introduced. XOR linked list performs the operation of doubly linked list only. It can also go in forward direction and backward direction. But the only difference here is, in XOR linked list, it only maintains one pointer. So with the help of one pointer, we can traverse ahead also and backward also in XOR linked list. So let me now show you one example how XOR linked list would look like. So let us see now how XOR linked list would look like. So this is the first node of the XOR linked list, this is second, and this is the third node. And here the data value is 1, here data value is 2, and here the data value is 3. So we know that XOR linked list only maintains one pointer. So only one pointer. And what does it store in one pointer is the XOR of its previous value and next value. So what does I mean? So here you can say it is the first node. So previously it doesn't have anything. So we can say that its previous is null. And its ahead one is 2, data value 2. So what next pointer would be storing here is null XOR with 2. Similarly here, what this next pointer would be storing, this next pointer would be storing its previous value and next value. What is the previous value? Previous value is 1. So 1 XOR, what is the next value? It is 3. Similarly, what it will store? Its previous value is 2. XOR with next value. Next value is nothing, that means it is null, so it will be null. So this is what our XOR linked list would look like. But you might ask the question, okay, we maintain this pointer, but how it is a kind of doubly linked list? How we can traverse in both the direction? So let me show you now. So this is the linked list that we have seen so far. So let us see if we are standing here. So what does it store in its next value? Next pointer. So its next pointer is storing previous value XOR with next value. So this next and this next is different. This is a pointer and this is the representing this data value. So don't get confused with it. So this next pointer is storing like this. So here previous is 1 and next is 3. Now if we want to go in forward direction, how will we go it? But before that you need to know the XOR property. So what XOR property? XOR property of like elements. So if you XOR two like elements, they will cancel out each other. If you XOR like elements, they will cancel out each other. We know that 0 XOR 0 is 0, 1 XOR 1 is 0. So like elements cancel out each other. So you need to know this property. So with the help of this XOR property only, we can go forward and previous node to our linked list. So how we will do this? So let us see. So the next pointer is storing previous XOR next. So if we want to get the next data value, so next data value is 3. So we have something like this in our next pointer, previous XOR next. Now we need to do some operation and we again want to get this next. So how we can get this next? So we can XOR it with previous value, previous data value, then only they will cancel out each other and the remaining answer will be next only. So what we are doing, we are indirectly getting the node value of its next element. So this is how we are moving forward. So in this case, previous XOR next is this. So we will XOR it with previous is 1. So we will get 1 and 1 will get cancel out and we will get 3, and this 3 is nothing but the next data value. Similarly, if we want to go backward in our linked list, what we can do, we can take our current next pointer. Our current next pointer will be storing previous value XOR next value. So if we want to go backward, we need to XOR it with the next data element. So next data element is 3. So this 3 and 3 will cancel out each other and we will get 1, and this 1 is the data value of the previous node. So this is how we are going into forward and backward direction. So let me just summarize how we will go in the forward and backward direction. So to go in forward direction, we will take our next pointer. So next pointer will contain previous data value XORed with the so let me just erase this, XORed it with the next data value. We can XOR it with the previous data element. So this is how we will go in forward direction. And for backward direction, we will take our next pointer and XOR with the next data value. So our next pointer will be storing previous XOR next. So we can just XOR it with next. So we will go on to the previous node's data element. So this is how we will go in forward and backward direction with the help of XOR linked list. So this was it about the theory of the XOR linked list. Now what the question is asking us to find out is complete two functions, that is get list and insert at beginning. Insert at beginning. So in this function we need to insert node at front of our XOR linked list, and in this function we will be given a linked list and we just need to take its data value and store it in some vector. So this is what we need to compute in this question. So let us understand first this insert at beginning function and how will we implement that, and then this get list is very easy. So let us understand how we'll first complete this insert at beginning function. So initially there will be no node in our linked list, so our head would be pointing to null. So let us see if we insert one node in our linked list. So it will be, let's say, 1, and its previous pointer would be pointing to null and its next pointer would be pointing to head, and head in this case is also null, so it will be null. So we are inserting at the beginning, so that's why we are inserting before head, because inserting at beginning means insert to the left side, not the right side. So that's why. So we added one element or one node in our linked list. After that we need to change our head from null to this one. So our now new head will be pointing to this one. So let's see if we insert another element or another node in our linked list. Let's say 2. So for 1, our both next pointer will contain null XOR null. So we will write also what we are storing in our next pointer. So let's say if we insert 2 now. So just let me remove this head. So if we insert 2 now, its previous would be pointing to null and its next would be pointing to head, and head in this case is 1. So it would be pointing to 1. So 2's next pointer would be null XOR 1. Okay, so till now it looks fine, but it is not fine. 2 is pointing to 1, but 1 is pointing to null. You see, 2 is pointing to 1, but 1 is pointing to null. This should not happen. 1 should also point to 2. This happened because initially before inserting, this 1 was alone. That's why its previous pointer was null. But when we inserted 2, it should update its previous pointer from null to 2. So that is what we need to take care of. So we will have one if condition before we move our head to next position. So before we move our head to next position, we will have one if condition. If there is already a node present in our linked list or not. So if already a node is present, then we need to update the head's next pointer value. So this is what we need to take care. Now how will we update this next pointer of our head? So let me just erase this. So you see that head's currently next pointer is storing null XOR null. But what we want? We want 2 XOR null. That means first we want to remove this one null. So how we can remove this one null? We will use the XOR property. So we have this next pointer as null XOR null. We will XOR it with another null. So this will remove and we will get only null in our next pointer. So this is the first step. So what we will do in the first step, whatever next pointer we will have, let's say next PTR, we will XOR it with null. Then what we need to do, we just need to have this 2 element before. So simply we will XOR it with 2, or in this case this 2 is nothing but, let's say we give it a name of new node. So after we XOR it with null, we need to again XOR it with this new node. So let's say we store this value in some variable, let's say temporary. So again in the next step we need to XOR temporary with new node. So after we do this, we will get our next pointer to be 2 XOR null, and we can then replace this null XOR null with 2 XOR null, and this will now be pointing not to null, this will be now pointing to 2, and this will be pointing, this was already pointing to 1. So this is how we inserted node in our linked list. So similarly, if we insert one more element, these same steps will follow. So hope you understood this insertion part. So now let us see how we will write the function for getList. So what we need to do in this getList function is, so let us say we are given this linked list. So we just need to return the data values in an array. So we need to return 1, 2, 3. So we just need to return these data values in an array. So this is what we need to do. So how will we do it? So we just we just need to take the head data value and push it into our array. And after pushing this data value, we need to move our head forward to the next node, and then we will do this similar thing. Now how we will move forward, we have already seen. So to move forward in our XOR linked list, what we will do, we in our next pointer we have this value previous XOR next. So to move forward we would XOR our next pointer value with previous data value. So if we do this, previous will cut and we will go to our next value. So this is how we will do, but we will also maintain one temporary variable to keep track of this previous value, because when our head will be here, we need to have this previous value as well. So for that we will keep another variable, another pointer, which will give us the previous value. So this is how we will do it. So let us write the code now and understand in more better way. So let us first write this getList function and then we will write the insert function. So in this getList function we need to return all the data elements in our array. So let us initialize one array answer which will store the data elements. Now what we need to do, we need to also initialize one pointer variable that is previous, that will keep track of the previous node value. So initially it will be null. And now what we need to do, we need to traverse with the help of our head pointer until it reaches the end of our linked list. So while head does not become equal to null, head does not become equal to null. So when this head will become null, that means we reach the end of our linked list. So till then we just need to keep pushing our head's data value into our answer. So what we can do, answer dot push back head's data value. And now what we need to do, we need to move our head pointer ahead. So how we can do that? So head equal to XOR of previous value XOR with head's next pointer. So we have seen how this will work. So npx. So here head's next pointer is denoted by npx, and we are doing XOR with the help of this utility function that they have provided. So this will return us the XOR value. But before that we need to make one temporary variable, temporary pointer which will store the head, so that we can also move our previous pointer ahead to our current head position. So when this head will move ahead, we also need to move our previous pointer also. But if we move our head ahead, so we can't move our previous pointer to the previous head location. So to keep track of previous head location, we will first store our head in one temporary variable, then we will move our head pointer ahead. Now after head pointer will move ahead, we will also move our previous pointer to old head location. And what is that old head location? It is nothing but temp. And in the end we will just return our answer. So this is how this getList function will work. So let us now write the insert function. So what we need to do, first we will create a new node. So how we can do that? So node star, and we will give this new node name as new node only. So node star new node equal to new node of data. So it will carry this given data inside it. So now we have created this new node. So what we need to do now, we just need to handle its npx pointer. So what this npx pointer will store, previous value XOR of next value. So since we are inserting this at the beginning of the linked list, its next value will be head value and its previous value will be null, because inserting at the beginning means inserting to the left of our current head. So if we are inserting left of our current head, that means current node's next value will store the head value. So let us write that now. So new node npx will store XOR of what? Previous value XOR next value. Next value is what? Next value is head. And what is previous value? Previous value will be null, because there is nothing to the left of our new node. So we will XOR these together and this will be our stored in our next pointer. Now what we need to do, we need to make this new node as our new head. So head will be equal to new node. But before that, what we need to do, we need to also change the head's next pointer. We need to update head's next pointer, because now we have added the new node in front of it, before it I mean. So we need to update head's npx pointer. So for that we need to write one condition that we have seen in our drawing explanation as well. So if our head is not equal to null, that means there are more than one node present in our linked list. So we will update our heads npx pointer. So let's say how we will do it. First we need to XOR it with null, and then we will XOR it with new node value, because we need to cancel out one null value as we have seen in the drawing explanation. So we will store that first in one temporary variable. So temporary will store XOR of heads current npx, and it will XOR it with the null value. So head npx comma null. After that what we need to do, we need to change our heads next pointer now to head npx to XOR it with new node value. So temporary and new node. So if there are multiple elements already present in our linked list, that means we need to change the previous node's npx pointer. So to change it, we will first XOR it with null value, so that one of its like previous pointer becomes empty, and in place of that we will place our new node's value. So for that we are again XORing it this value with our new node value. So its previous value will now become new node, and its next value will obviously whatever it would carry. So this is how this insert function will work. So let us see. So before that we need to change it to comma here, and here also comma. So this is how it will work, and in the end we need to return our head also. So return head. So this is how it will work. So let us see if this get accepted or not. So we need to comment this entire thing out. This was just given us for reference. This was already implemented in the main driver function which they have provided. So we don't want to uncomment this. So let me just comment this entire thing, and yeah, now I think it should work fine. So yeah, our code got accepted. So hope you learned from this video. Thank you.